Hi, I am Prakhar Kumar, and today we will be studying about the notations that are used in algorithm. There are three types of notations that are used in algorithm: big O, big omega, and big theta. So let's get started with the big O. Big O or upper bound, or you can also say this as worst case. This is like a value above which the algorithm cannot go. It's like a ceiling above which the algorithm can't go. It's the worst case of an algorithm that this is the slowest algorithm can run. For example, I'll go for searching and we have to search for 6. And the searching algorithm is like in which we compare 0, 0 value first, then 1 index, then 2, then 3, then 4, then 5. So in this, the worst time complexity to find 6 is big O of n, which is we have to find the last element. Or you can understand this from here. This is the function, and after this point, n naught, f of n will not rise or will not go above the gn, which is the big O function. And now let's study about the big omega. Big omega, which is, you must have guessed it by right now. Big O is the upper bound, big omega is the lower bound, or you can say the best case of an algorithm. For example, we have to find 1 in this array, and same algorithm we are using, we have to find 1. First, we will look for 0, 1, 2. Let me change the was 0, 1, 2, 3, 4, 5. But in this, we have to find 1, and 1 is in 0 index. So in first iteration only, we will be getting the value. So the time complexity of this is big O of 1. You can understand by here also, f of n is the function and cgn is the function of big omega. Below this, a function cannot go. This is the best time complexity of a particular algorithm. And big theta tight bound. This is basically in which f of n, which is the function, lies between the big O and the big omega. The function which lies between both of these are the theta function. For example, for loop, it is running from 1 to n. So here the big O of the function is n, and big omega of this will also be n. So with this, theta is also n. So this is big omega, big O, and big theta notations that are used in algorithms. Mostly we will be working with the big O only. We will be finding the always finding the worst time complexity only most of the times. And this is the table which you can refer for your reference to remember what these notations are. Here you can refer to this table. Easy way to learn. Now the next is the growth comparison summary. This is slowest to fastest comparison. You don't have to learn this. When we will be learning throughout this course, you will be eventually getting what this is written. You don't have to fear this. It basically means log n takes less time compared to n to grow in function. So it is basically like how the function grow. For f of log of n might be taking this to grow, but log of n might be taking the straight line. The n function will be taking the straight line, and n log n may be taking more time, or you can say the fast time to grow. So this is basically from fastest to or slowest to fastest function. Yes, you have to remember one thing is that the You have to remember this, that exponential exponential function have higher rate of growth. That means takes more time. For example, a power n, where a is greater than 1, and polynomial function have lesser rate of growth, takes more time to grow. So polynomial function are faster than the exponential function. Example of polynomial function are n, n square, n cube, and so on. So remember this, that polynomial function are faster than the exponential function. Now let me tell you about the speed comparison also. This will give you a understanding of how things are working. Speed comparison. So the fastest is the big O of 1, which is constant. This is the fastest the algorithm can run. Big O of log n, this is logarithmic function. Then we have big O of n, which is linear function. Then we have big O of n log n, which is linear arithmetic. Then we have big O of n square, which you can say quadratic function. Then we have big O of 2n, which is just now I explained, exponential. You can also say this as or polynomial function, exponential. And then the slowest we can take is the factorial. Factorial are the slowest algorithm can run. Now with this, there are small notations also. For example, these are not used much, but it's better to understand. There are small notations also, small o and small omega. Small theta is not there, only this is there. Small and small omega is simply just, let me go above and explain you. Here, a function f of n can be equal to c dot gn. It can be equal also, big O. But in small, it cannot be equal. It has to strictly above that from a particular function. It has to be strictly above from a particular function. And for the big omega, it is said that it can be equal or less. But for that, it has to be strictly less from a given function. For example, if I go down, yes, and if we write here, let's say big O of n, is it big O of n square? Big O of n. This is small o I am writing. Let me change the boldness of the pen. It is the small n, and this is the small n square. So is this correct? Big O of n square? Yes, it is correct. Is it correct? Big O of n function? Yes, it is correct. Is it correct? Small of n square? Yes, it is strictly above than the f of n function. Yes, it is correct. But this is wrong. This is Wrong, because it has to be strictly above when there is a small notation we are using. So this is the notation that we use in the algorithm. In next lecture, we will be learning about the recursion, how to solve a recursion, which is more asked in every semester exam or college exam, even in competitive exam also. It is very popular question asking from recursion. And we will be learning basic log formulas also from for solving the recursion function. So meet you in next video. Thank you.